Hi everyone, I am Lavam and I am currently preparing for placement and learning DSA and backend development. And this channel is my journey of learning in public, and whatever I learn in each day, I will try to explain it here in the simplest way possible. So in today's video, we are going to solve LeetCode T095, delete middle node of the list. LeetCode 2095. And before writing the code, let's first understand the problem statement. We are given the head of the linked list, and our task is to delete the middle of the linked list. And first we draw linked list 1, 3, 4, 7, 1, 2, and 6. So this is our linked list, link and a linked list contains 7 nodes. And what will the middle of the linked list? Middle 7 divided by 2 is to 3. So 3 is our linked list, is our middle of a linked list. And let count, if we count from index 1, 0, 1, 2, 3, this one. So the middle node is 7. And after deleting after deleting 7 from the linked list, our resultant linked list will be 1, 3, 4, and 1, 2, and 6. This is our resultant linked list. So first of all, we are thinking about brute force approach. In brute force, fir- in a brute force approach, first we count number of linked list. Like, first we count number of nodes in a linked list. Okay, and then traverse traverse again and delete middle of the linked list. But the problem is, the question is, can we solve this by one traversal? Yes, we can solve, and we can solve this question from with the help of slow and fast technique. And basically, in a slow and fast technique, we have two pointers with slow head and fast equal to head. Idea is simple. Idea simple that we move slow pointer from one step, slow the next, and we move fast pointer with two steps. when fast reach it is the end of the linked list, and, and when fast reach at the end of the linked list, we find that slow is pointing to the middle node of the linked list. And now we do try run. Let our linked list was 1, 3, 4, 7, 1, 2, and 6. And according to slow and fast pointer approach, we initialize slow and fast at the head. So initially both slow and fast point to the first node. So move them. So after the first iteration, our slow was here, fast, first iteration. And after the first and move again, or move again, slow, fast, fast, and move again, fast, fast. Here. Now fast has reached at the end of the linked list, and slow is pointing to the middle of the linked list. Uh, But there is a one problem in this thing, that if we directly delete this linked list, this node, we lost the connection between that part of the linked list and that part of the linked list. To delete the middle node, we also need access to the previous node. That's why we maintain pointer called That's why we maintain a pointer called previous. Now we will do dry run with the previous pointer. 1. Again we draw the linked list. 1, 3, 4, 7, 1, 2, and 6. Slow pointer, fast pointer, and previous pointer equal to null. And here, first we store previous equal to slow equal to slow that next, and fast equal to now. 1, 3, 4, 7, 1, 2, and 6. Previous points to slow. Previous points to slow. So previous is here. And slow moves to 3, means slow equal to slow that next, and slow is here. And fast move with 2 steps. So fast dot next, fast dot next, fast. And in a iteration second, 1, 3, 4, 7, 1, 2, and 6. Now again previous points to slow. Slow moves to one step and and fast move to two step. Fast the next fast. And we have iteration third. Iteration third. 1, 3, 4, 7, 1, 2, 6. Previous points to slow. And slow moves from one step. And fast move to two step. Fast next and fast. So now we can say that in next iterations, fast go out of bound. So delete the middle node. Now we have this one, and we need to delete 7, 7, and we can directly point that previous next equal to slow, slow the next. Means we directly connect this part and delete slow. And complete code is now we are right now we are write complete code. Delete middle, and we have access of we are given a head pointer, and as we discussed we are using slow, and we are using slow and fast approach. And before that, if there is only one node, if there is only one node, delete it and return null. If head equal to null, or next equal to null, then return null. Here is a list node slow, slow equal to head, and list node fast equal to head, and list node previous equal to null. So when we stop traversing, when fast is not equal to null, and but next is not equal to null. So and first we point previous equal to slow, move slow with one step, move fast with two step, after while loop we can move previous next equal to slow that next and delete slow and return head. one and time complexity is big of n, and a space complexity is also big one of 1. and and these problem are application of slow and fast pointer technique. And now we are solving this on our LeetCode platform. Or as we check, first we check is linked list contain only one node. If add equal to null and equal to null, return null. And next node slow equal to head, fast equal to head, and previous equal to null. And again, while fast is not equal to null, and while fast is not equal to null, and fast is not farther next is not equal to null, we first previous point to slow. Now slow move with one step and fast move with two steps. And after the ending of while loop, we point previous of next equal to slow the next and delete slow pointer and return next. And minute 1 minute, if head equal to null and head the next equal to null, return null. Slow equal to head, fast equal to head, fast is not equal to null, and fast is not equal to null, previous equal to slow. Oh, yeah, we need to move it to a step. This is also a today's daily problem. And so in this problem, we used slow and fast pointer technique to efficiently find and delete the middle node. And and I am currently preparing for a placement and documenting whatever I learn each day. If you are also on a similar journey, feel free to join me and let's learn and grow together. Thank you for watching. See you in next video.